what's up? Today we're going to learn given a perfect square number and we have to find square root of n. Now given a perfect square n, find square root of n. Basically, if you have a number like 25, now what is square root of n? Nothing but 5, right? This is known as a perfect square number, and the number which we are multiplying with itself is known as square root of this number. Okay, if a number is given as perfect square, it will be perfect square only. But during interviews you can ask him, like for example, sir, is this a perfect square number? There won't be any invalid inputs, right? So I have to check for invalid inputs or something. Like for example, 10, is it a perfect square number? No. Minus 3, is it a perfect square number? No. So basically like this. So invalid inputs, maybe it can be a string also, a b, or it can be anything. Okay, so when a question said like given a perfect square n, then the question the input will be in perfect square only. Okay, if in interview, if you have any doubt, you can ask the interviewer, you can get clarified. Okay, now what is 1024? Square root of 1024 is 32. Yes, see, if given a number is a perfect square number and you have to find the square root of for that number, right? So if it is found, then return that number, else if agar ye true hai, if it is a square root, then return square root, else return 0. Okay, for example, if n is equal to 25, the output should be 5. If n is equal to 36, the output should be 6. If n is equal to 1024, the output should be 32. And if n is equals to 10, the output should be 0. Okay, if n is equals to 13, the output should be 0. Got it? So as I already said, we have to take different function name. Here I'm taking sqrt, square root. Here I'm taking n. Okay, now so we need to call that function also, right? So I'm directly printing that function. Okay, sqrt of n, right? See, I have taken the input here and I'm calling that sqrt of n, and when it is returning something, this function returns something, it automatically prints over here. Okay, now here what I have to take, here I have the n number, right? So the simplest thing is nothing but we need to iterate through every number, right? Basically we have to iterate to every number, and let's do one thing. Okay, we will iterate to every number. Int I is equals to 1, I less than or equals to every number up to n, right? And I plus plus, like this. If I into I equal to n, then you have to return what? I only. Yes, if there is nothing, then you have to return 0. If see, this loop is going up to 25, right? Assume the input value is 25 and this loop is going up to 25, but as when we are checking here, I into I equal to n, is it going up to 25? See, now I is equals to 1 into 1 equal to 25? No. 2 into 2, which is 4 equal to 25? No. Now I equal to 3 into 3 equal to 25? No. 4 into 4, which is 16, equal to 25? No. 5 into 5, is it equal to 25? Yes. Now let's see the, is it giving the output or giving some garbage value or something. Okay, now the simple 125, we'll check if this giving me 5 or not. Yes, it is giving me 5. Okay, yeah. Now we'll check for some other number. 36, yes, it is giving 6, the right answer. Now 1024, is it giving me the right answer? 32, yes, it is giving me right answer. Now what if it's not a perfect square number? 10, then we'll have 0. as you said here. Now 13, is it give me 0? Yes, it is 0 because it's not a perfect square number. Now coming to the time complexity. Now what is the time complexity? Yes, now coming to this thing, this is the code we have written, right? Now is it having order of n time complexity? Because we are iterating through 1 to till n, right? So basically you can say that order of n only, right? No, we should not think like that, because as we are saying that it is iterating through till n, order of n, it's not a bad thing, but can we reduce it? See, yeah, yes, of course, because what we written in the code, it does not allow me to go till up to n, right? Because if for example n is equals to 25, if I are taking the input, then when I is equals to 5 only 5 iterations happen, then 5 into 5 giving me equal to 25, then I'm returning. Return is nothing but it will break out the loop also from the function. Also it will directly return the value, it will print, right? So basically here I am doing only 5 iterations. Yes, so basically now what I can say here is, if a number is given 25 and it is happening 5 iterations, because I is equals to 5 and 5 into 5 equal to 25, that means can I say that it is root n? Yes, can I say that it will be, the time complexity will be root n? Up to root n iterations only it will happen. For example, n is equal to 36, up to 6 iterations only happens. If n is equals to 1024, up to 32 iterations only it will happen, and we'll have the result also, right? Understood? But in the worst case, see, if it is not a perfect square number, then obviously it will gone up to n. But the question says that it is a perfect square number, then we'll have a perfect square number and the iterations will be up to root n only. And space complexity for this is order of 1. Order of 1 can we say like order of constant. But there is also another approach. For example, sqrt square root of n, it has two ideas. Idea 1, order of root n. Okay, now idea 2 is of log n. Log n is much lesser than root n. Okay, but for this video we'll see only order of root n. Okay, for order of log n we'll see this in advanced level. Okay. For this take that time complexity will be order of root n. It is very much optimal. Okay, but for order of log n we need to go in advanced level. Okay, so later on this upcoming videos we're going to see the time complexity, how we have to solve it in order of log n. So that's it for this video. Thank you so much for watching. Goodbye.